Today we are talking about how electric charges are created. Our primary vocabulary words for today are friction, conduction, induction, and polarization. Each of these words are a form of movement of electrons, and you will need to be able to identify an illustration that is representing each of these words, as well as interpret statements, either giving the definition properly or correctly interpreting examples of each of these. And it's all just based upon what the electrons are doing, what object they are on, how they move around and relocate. Before we get into the specific types of transfer, let's just go over some basic vocabulary that I hope is review for you. Conductors and insulators are the primary vocabulary words you need to know here. Conductors are going to be materials that are very good at transferring electrons. These tend to be metals on the periodic table. So if we recall looking at the periodic table, there were various columns, and each of those columns are going to have different types of structures for the atoms in those columns. Based on the arrangement of those valence or outside electrons, we could make predictions about whether they were more likely to lose or gain their electrons. So if we are looking at the outside or valence structure of our atoms that are used to make up metals, these are materials where the atoms are going to freely allow those electrons to come and go, okay? They are going to be looking to pick up electrons. We say that the electrons are loosely bound because electrons come and go very quickly, and so this makes them good conductors. You should have learned about conductors for other things besides just electric charges. So when we talk about conductors for all types of energy, metals are going to be good conductors, and it's because of that outside valence electron structure. Insulators are going to be materials that are made of atoms where they actually are wanting to gain electrons and then they want to hold on to them. We say that the electrons here are tightly bound, meaning once they've collected those electrons, they're not going to let them go as quickly. So in general, insulators do not do a good job of transferring energy, and in this case, it's electrical energy we're discussing. So these are going to be things like styrofoam, plastic, rubber. So it doesn't mean that energy can't pass through these materials, but it's going to happen at a very slow rate because they're just not going to allow those electrons to move along as easily. All right, so when we talk about friction, a lot of times when I ask students to demonstrate friction, they'll take their hands and they'll rub them back and forth, and we talk about how, eventually this creates thermal energy. Well, I want you to just imagine having your two hands, and I want you to make these hands move in opposite directions, and I want you to imagine that we could see the electrons on the surface of your hand. So as one of your hands moves across the other, I want you to envision electrons being picked up, removed from one hand, and physically transferred onto the other. And so that's what these illustrations here on the right are trying to show you. They have two neutral objects, the rubber and the fur. Each of these objects has both positive and negative charges. Again, any type of transfer of electrons or electric charges is always going to be the electron's fault. We talked about the atomic structure. They are the ones on the outside. So we have an even number of positives and negatives for each of these materials individually. From that friction, what happens in this case is the electrons on the fur are going to be moved and pulled onto the rod. Now, how do I know that? Because the picture here shows that the rod is the one that has the excess of negative charges. So the rod in this example is the object that picks up those electrons. So friction is the physical relocation, because we have two surfaces that rub against each other where the electrons are physically pulled off of one and collect on the other. In this case, we end up with two charged objects. My rod is going to have an overall negative charge, and as a result of losing those electrons, my fur is now left positively charged because of the deficit of electrons that it has. Conduction is going to be the transfer of an electric charge because electrons physically relocate once again. But this time we do not need a rubbing motion. We do not need one object to slide across the other. Instead, they simply have to come into contact. So if we think about being shocked whenever we touch something metal, that is a buildup of an electric charge that's sitting on one of the two objects. The moment the two objects touch, the electrons are looking for a place to go where there is not so many other electric charges. Remember, we've learned in a previous lesson that like charges repel. They're trying to get away from each other. So if there is a buildup of electrons on one of my objects, the moment they touch, those electrons are going to run off of one object and get on the other because they're trying to leave the other electrons. This is called conduction, and our key word here is that we are looking for contact. Touching, okay? So if we look at each of these examples, all of them have some sort of material that has some sort of electric charge. So in this case, the sphere is electrically charged, the plate is neutral, and so as soon as they touch, those electrons physically move from the charged object to the other object, okay? In this illustration, they are trying to show by the overlapping of the two objects on the illustration that they are touching. Once the objects are on the new surface, notice that the electrons then spread out. Remember, I just said like charges repel. So in both of these illustrations, they're showing you the idea that once those electrons have moved onto that previously neutral object, they are now going to spread out. So when we look at the picture of this cute little boy here, this must have had some sort of electric charge. The moment the boy touches the sphere, those electrons are trying to escape the sphere, so then they go all over the boy. Your individual strands of hair can be moved. So what ends up making the boy's hair stand up is the fact that the electrons on those individual strands are trying to get as far away from the other electron as possible, and that's what makes his hair stand on end like that. All right, this next vocabulary word is called polarization. Polarization and induction are words that students really struggle to understand. So we are first going to talk about polarization. And if you look at my illustrations here, I have some brackets that are here to try to focus your eyes on the part of the picture that actually represents polarization, okay? So polarization is a response that happens within a neutral object. It says here on the slide that the charges, which would be the electrons, are going to rearrange themselves. The object itself is actually neutral. So in this case, we are not physically relocating our electrons by removing them from the material. The electrons are going to rearrange themselves within the object that they're on, and that rearranging is going to be temporary. Remember, in a neutral state, we have an even number of positives and negatives, and they will both evenly spread out. And so what we're trying to illustrate to you in this image right here is that we have the positives and the negatives evenly spread out so that overall this is a neutral object. When the electrons have a reason to relocate, when they have a reason to move, then they will respond so that opposites attract and like charges repel. So in each of these pictures, there is an additional object, and that is what's going to be responsible for the electrons leaving this balanced neutral state that I have highlighted in blue. I do not want you to focus on object number 2 in any of these pictures right now. Polarization happens within one object, and that one object is going to then have its electric charges move so that they are going to separate into an area, a side, a concentration of charges. So overall, on this sphere here, the negatives are on the left and the positives are on the right. So this sphere is currently polarized because we have a pole, an area, a side, a half that is negatively charged. And then on the other side, it is positively charged. So think of the word polar from chemistry when you learned about water being a polar molecule. It was because overall there was one side of the molecule that was positively charged because of the hydrogens, and one side of the molecule that was negatively charged because of the oxygens. So this is the idea that we have in each of these pictures. So when we look at this sphere here in the middle, now all of the positives are on the right side. Yes, this picture shows them still paired up, positives and negatives, because they are still there. But if you look, the right side is the location of all the positives, and the left side is the location of all the negatives. Okay, so within each of these examples, we have an area for each of the charges. They have separated out into different poles, and that's what we call polarization. Okay, now again, polarization is temporary. It happens within a neutral object, so notice that none of these examples have electrons leaving that particular object. They are still there. The object is technically neutral in the sense that it has the same number of positives and negatives. They are just temporarily organized so that we have a concentration of negative and concentration of positive, and this is what we call polar. Once the other object that gave them a reason to move in the first place is gone, they're going to spread back out and they're going to come back to this state where they are evenly dispersed in a true neutral object. That is polarization. Okay, now let's talk about induction. Induction is going to be very closely related. However, if you notice now, I am asking you to focus on this part of the picture. So if we look at the two slides, I have the same example in both slides. However, what I'm drawing your attention to is different. In polarization, we were focused on the neutral object. Here for induction, I want you to focus on the object that actually has an electrical charge. So, electrically charged things create reactions, responses to other objects. Either their abundance of electrons is going to cause the electrons to want to leave it, or their abundance of electrons is going to want to cause other objects to react or respond to it, right? So induction is going to be a charged object that causes some sort of response or reaction because it gets close to something. So conduction was touching. Here, my two objects are not touching. If you notice, there is an empty space here in between the rod and the sphere. There is an empty space here between my two balloons, okay? There is an empty space here, right? You guys get the idea. These objects are not touching, so I use the word proximity, which means just to be close. Now, this is a relative term, being close, but I need you to understand the difference between conduction and induction is that in induction, there is no touching. There is always a gap in between our two objects. For induction, as long as my object has an electric charge, if we bring it close enough to another object, it's going to cause a response or a reaction. Now, what is that reaction going to be? It depends on the other object, okay? In the case of this example, this neutral object had all of the electrons move towards the rod because opposites attract, leaving the opposite side positive. In this example, both of my balloons are negatively charged. So when I bring them close to each other, like charges repel. So the balloons are actually going to physically push away from each other. So these are the focuses that I want you to catch in our examples that we have here. So this charged rod comes close enough to create a response. These charged balloons get close enough to create a response. What that response is irrelevant for identifying induction. Okay, so those are your 4 types of charge transfer that you need to know. Now, there are some specific examples here that I have illustrated. We have our example here shows that we can create permanent charges because once induction occurs and those electrons are moved, we can then, force those charges to maintain those objects to maintain their charge. And we have another example here where the charges have moved because of induction, and we've moved them so that the place that they have gathered can then be separated. So we're left with 2 separately charged things. But these parts are additional results that happen after the induction. So one more time, the word induction says that we have a charged object that comes close enough to something else to create a response because of the electric charge, okay? There is another word here that I need you to know. It's not one of the 4. We've now covered the 4 main vocabulary words. But if we look a little bit closer, we want to talk about what's happening in this picture. So this particular step right here is showing us something called grounding. And the focus of grounding is this part of the image. We have electrons that have built up on our object, and those electrons are now going to be physically allowed to escape because an additional object came and gave it an escape route. In this example, it's a person's hand. In other examples, it's just a wire that is attached. Some other foreign object comes into the picture and allows an escape route. So if we look at this image here, they are showing you we have multiple things being demonstrated in this series of pictures. When we talk about the word grounding, we are talking about this step. These charges are able to actually physically leave because of the presence of this wire. The electrons will move onto the wire, and then they have left the sphere. So as a result, the sphere is permanently left positively charged because it is lacking electrons, okay? So make sure you understand what moment we are focusing on when we talk about grounding. Okay. This concept of charge distribution is really simple. I have 2 objects. I'm going to find out what are their electrical charges. I'm going to take those values, I'm going to add them up. Then I'm going to divide it by 2. That is going to tell me the electric charge of the 2 objects after they have then been removed. So let's look a little bit closer at the picture. I have a 12 and a 0. If I physically bring these 2 objects together so that they touch each other, now this represents one large object. Because they are now physically connected, all of the electrons have the ability to move throughout the entire space. So all of my electrons are now going to spread out between the 2 spheres because they are now acting as one big object. And if we understand that like charges repel and opposites attract, what we should see is that those charges are going to spread out evenly. So now I'm going to take the 12 plus 0 and I'm going to say that I have a total of a positive 12 charge. Well, if they are evenly spaced, that means a positive 6 is present in each of these spheres. So now, if we take the 2 spheres and we pull them apart, we separate them, each one of them has a resulting charge of a positive 6. And this A and this B have the same electric charges. So what do I need you to remember to understand? Charge distribution says, so we have two charged things, they're going to come together and touch, and then we're going to separate them apart. So if I ask you for the value, you're simply going to take the charge of the two objects and add them up. Because we're later going to separate them after they've had a moment to evenly disperse, we're going to take that total, we're going to divide it by 2, and that's going to give me the charge on each sphere. All right, lightning is an example of induction. That needs to be noted in your notes. It needs to be understood for test purposes. Lightning is an example of induction. Now, how does lightning work? Well, we have a buildup of electric charges that happens in the clouds. The earth is neutral. I expect that is common knowledge. So that means that we have positives and negatives evenly distributed in the ground, okay? When we have this buildup of charges, this means that we are going to see polarization take place within the ground. So as the bottom of my cloud becomes negatively charged, the electrons that are located in the ground here at the surface, they're going to want to move deeper into the ground. They're going to try to get farther away from that negatively charged cloud. And so if each of these electrons then moves deeper to the ground, well, what does that leave on the surface? That leaves a bunch of positive charges. So what happens next is that opposites attract. So our lightning, the bolt of lightning that we see, is really all of these electrons funneling down at once for one massive surge or movement of electric charges. That's what creates lightning. It is the abundance of electrons that move all at one time that create that electrical lightning strike that we see, okay? Now, you need to know lightning is an example of induction. It helps if you understand that we have a charged surface of the cloud, which creates polarization in the ground, and eventually that charge in the cloud becomes strong enough that those electrons will physically move down to the ground because opposites attract. All right, I have one last word for you, and it is called electric shielding. People can be struck by lightning while driving their vehicle and have zero damage to the person. Now, in order for this to be a true statement, the person needs to be safely located inside of the vehicle. In theory, the windows should be up, the doors should be closed, okay? The idea behind electric shielding is that because your car is a hollow object, obviously because you sit in the empty space inside, the electrons that are coming down from the lightning bolt are going to spread out around the car. Because it's hollow, the electrons are going to spread out on the outside. As long as you are safely inside the vehicle in that hollow space, those electrons do not hurt you, they do not get to you, because they are trapped on the outside. So electric shielding is this idea that there is an electric field, meaning the electric charge inside of the car is zero, no electric charge, it's neutral. And so because there is no electric charge, you do not get electrocuted. The charges themselves distribute on the outside of that hollow object, okay? So let's just take a second and let's recap the vocabulary words for today. The primary vocabulary words are going to be friction, which is, keyword was what? Rubbing, right? Electrons are going to physically relocate because they are pulled off of one object onto the other when they slide in opposite directions. Then we had conduction. That was direct contact. So the key here is that we're looking for things to touch. This requires one object to already have an electric charge, and then it just needs to come in physical contact with the other object. Then we had Polarization, which is the separating of electric charges of a neutral object. So this is an object that is neutral, so we have both positive and negative charges in equal amounts, but the electrons are going to relocate so that we have a concentrated area of negative and a concentrated area of positive. Then we have induction, which is where we have an electrically charged object that is going to come close to something else in order to then create a response. So induction is an object that is already electrically charged and just simply is brought close enough to create a response. It does not interact physically by touching, and the electrons are actually not going to relocate. That object is still just charged because it didn't touch anything. Those electrons didn't get to go anywhere. If the charge is strong enough, those electrons can jump to the other object, and that is what happens in lightning. Obviously, the clouds don't physically come in contact with the ground, but the charge is strong enough that those electrons are then pulled. We've learned about Coulomb's law, where there is a force of attraction between those two objects, and if that electrical charge builds up to a great enough number, that force can actually cause those electrons to move, get pulled down to the ground, and that is what lightning is, okay? We also learned some smaller, less intense vocabulary words here. We learned grounding, and that was when we had an escape route for electrons to physically leave an object. We learned about charge distribution, which is when we have two objects with an electric charge. They come together and touch. The charges spread out. They separate so that they have even or equal amounts of charge in both of our objects. And then the last word was electric shielding, which is where we have zero electric field inside of a hollow object, but the electrons are distributed on the outside of that object.